when we talk about temperature and thermal energy, since both of them relate to the kinetic energy at the molecular level, it's easy to confuse between them. Temperature is a measure of the average kinetic energy of the molecules or compounds of a substance. In other words, it is related to the average speed or vibration of the molecules. It also just tells us how hot or cold a substance is. For example, if we look here, if we are representing the molecules by this blue and green shapes and the arrows representing their speed, the average speeds here are less than the average speeds here. You know, some speeds are larger here than here, but overall the average here is bigger than the average here. So because the average kinetic energy here is higher than the average kinetic energy here, then this one is at a higher temperature. Now, these two here, okay, it's difficult to see, but we have the same average speeds here than here, even though I have a lot more molecules here than here. So because the average speed of the molecules is the same, I mean the average kinetic energy of the molecules is the same, then both of these are at the same temperature. So they are at the same temperature here, but this one is at a higher temperature than this. Thermal energy, though, is a measure of the overall kinetic energy of the molecules of the substance. So for the pair of boxes at the left, even though they have the same temperature, the same average kinetic energy, since I have more molecules here, I'm going to have more total kinetic energy. So I have more kinetic energy, so I have more thermal energy here than here. Here also I have more thermal energy here than here, because I have more kinetic energy overall here than here. So this one is a higher temperature and more thermal energy than here. This one here is same temperature as this one, but has more thermal energy than this one. Now, one way to help remember the difference between temperature and thermal energy is using the example of amount of money that a group of people have. Let's say you meet up with a group of 10 people and ask them about the average amount of money they have in their pocket. Let's say they say $10. So the average amount of money that they have is $10. That means probably one of them does not have a penny, while another one has 20, and so on. So the average for the 10 people is $10. That's like this. Now, if you go to a group of people that has 100 people in it and ask them for the average amount of money they have and they say $10, that's like this. 100 having an average of 10. 10 having an average of 10. So it's same temperature. Now, thermal energy would deal with the amount of money that you can get, the total. So 10 times 10, that's $100. That's what you can get out of these if you ask them to donate that money. Now, if you ask these to donate that money, since they are 100 times 10, that gives you 1,000. So you get more money, more thermal energy here than here. Similarly, this would be like their average amount of money, $10, but this one, the average is $20. So more thermal energy here because I have, because the average, since the average is 20, that means for 10 people I'm going to have $200. Since each of the kinetic energies is larger, so I'm going to have a total amount of thermal energy that's small.